Okay, very good. So as I promised, it's 7:01, and since we've got quite a packed agenda, we're gonna kick off. Welcome everyone to this session. As you can see there in your screen, Model, Insight, Action, 5 styles of modern data integration. My name is Lucia Santamarina. I work in the sales side with C-Data Virtuality, and I'm very excited to be your moderator today. So 3 things that I need to share with you before we start. First of all, yes, this session is going to be recorded. We'll send you the link as soon as the recording is available. Secondly, you're more than welcome to share with us any questions that may arise during the webinar. For that, we kindly ask you to use the Q&A, and we'll try to address it at the end of the session. And in case you have any question or we run out of time during this webinar, we'll make sure that we follow up with you and get back to you only if you gave us a good email to respond to your question. That is in case we run out of time. And last but not least, we have included 2 polls for this session, to make it a bit more interactive and to break it down a little bit for you. That said, let me introduce you to the 2 amazing speakers that we've got today. The first one is Kevin Petrie. He's the VP of Research at BARC US. He's an expert on emerging technologies such as AI, data integration, machine learning, and he has over 25 years of experience working in these fields in different roles as an analyst, marketer, journalist. And one thing I think is really impressive about him is that he's a co-author of 2 books on data management. And the second speaker is no other than our founder, the founder of Data Virtuality, Dr. Nick Golovin, who has been working over 20 years on the different approaches on data integration, and he also holds a PhD in data warehouse and data integration. That said, this is done, and I would like to pass the word to our first speaker, Kevin. The stage is yours. Thank you very much. Welcome.
Thank you very much, Lucia. Really appreciate the introduction and the opportunity to join Nick and the C-Data, the team here, the C-Data Data Virtuality team. This is a topic that's near and dear to my heart. I was on the vendor side for a while. I was with Attunity for 5 years. We became part of Click, and we lived a lot of the trends that we're going to be talking about here, a lot of the evaluation requirements and the different adoption patterns. So why don't I jump right in here? I think the best way to frame the conversation is to talk about the role of data engineering. And when I say data engineering, I think this also applies to data architects who are going to help them architect their environments, who are going to help them make sure that they have the right access to data, and make sure that they're integrating data and provide in a way that provides the right access to their analytics teams. So data engineers are, in a sense, the primary throat to choke, along with data architects, when it comes to data integration. Data integration matters because organizations, as business environments grow more competitive, need to provide the right level of access to different diverse data sets. What's interesting about the market right now is that new tools, for example, taking advantage of generative AI language assistants, are automating more and more of the work of data engineering in terms of creating pipelines and so forth. On the other hand, there's a lot more demand for their services. There's much more demand in the business. And so we did a poll recently about overall demand for data engineers. Do you expect demand for data engineers to increase or decrease in 2024? And the responses were a resounding increase. 85% of 298 respondents said we expect demand for data engineers to increase in 2024. And in a sense, that's not surprising. The big 3 market trends that are taking place right now are A, data democratization. More and more business-oriented users are demanding access to data sets so that they can drive more and more of their decisions with hard evidence about trends. Data science, advanced analytics is also creating more demand for data, increasingly diverse data sets. They need fast, accurate, and diverse data. Now, on the positive side, tool modernization is helping data engineers. I talked about the automation trend, and organizations that use modern tool sets for data integration can achieve the flexibility that they need to improve the productivity of these data teams in providing the necessary level of data access. So what we've identified at BARC is that there are 5 primary styles of data integration. There are others too, but the 5 primary styles are extract, load, and transform, where data is being transformed on the target. Extract, transform, and load, a familiar pattern used for more operational data sets. Change data capture, which moves incremental updates. Streaming, taking advantage of platforms such as Kafka. And then, perhaps most importantly, data virtualization, which helps access data without moving it. And that's an important efficiency benefit for a lot of organizations. So each of these different styles, which I'll unpack, support different use cases. A critical point is that many styles work in tandem. And so a success factor for data teams is not simply which styles they support, but which styles they can support together. Now, some of the other patterns that I mentioned can build on these. So ELTL is a pattern that is being used, for example, to prepare text files for consumption by GenAI language models. There's also ETLT, where data is being transformed, loaded to a staging area, and then transformed further. The primary selection criteria for tools, data integration tools that are going to support these patterns, and I should say the selection criteria in terms of which integration style is going to make the most sense for your use case are the processing requirements. How much compute is being required, and where is this compute for servers you've already paid for on premises? More and more often, it's compute from cloud clusters, which are usage-based and can cost a lot of money. There's also the diversity and the complexity of data sets. There's the physical location of data. We'll talk more about why that matters. The performance SLAs that data teams need to meet to support applications and analytics projects, and then the available tools and skills. So data teams really need flexible tool sets. They need to learn new skills in order to adopt multiple styles. I'll unpack this a little bit further. ETL is the familiar traditional method of, for example, loading operational records, replicating them periodically, maybe once a month, maybe once a week, or once an hour, from relational databases and putting them into data warehouses. ELT is similarly periodic, and this is where you're ingesting, then transforming bulk loads once it arrives at the target. Change data capture, or CDC, is replicating incremental updates by most often and most effectively scanning change logs within the source database. Streaming is a similar pattern in that it's designed to replicate or move just incremental updates, has publishers and subscribers, and in between you have a change log or an immutable change log. So Kafka is an example here, Apache Pulsar, and it's going to receive topic streams and then send them out to different subscribers to those topic streams. I'll talk more about the use cases that make sense for. And then, of course, there's virtualization, which provides data access for data in place with virtual pointers, no replication or transfer required. So it's critical for leaders of data engineering teams and data architects to scope how each style is going to work in their environment. So now we can differentiate a little bit by workload and example use cases. ETL has light transformations of structured data. As I mentioned, this is often hourly or daily, might be more often. And so this can support traditional BI reports and dashboards. It can support, for example, finance teams that are putting together tabulations of quarterly sales to support financial reporting. It can support supply chain managers who are bringing together different inventory different inventory assessments from different factories and warehouses. Another example here is ELT. Now, this is where we've got more complex transformations. It's going to be higher processing intensity, and then it will make, and in those cases, it makes sense to transform the data not on an intermediate server or cluster, as with ETL, but rather transform the data once it arrives at the target. Oftentimes, that's going to be a cloud-based data warehouse. And the reasons the transformations are going to be more complex is that you have multi-structured or multi-source data. This can support a wide range of use cases, customer 360 projects, training of artificial intelligence or machine learning models also can work for ELT, where you're bringing in different types of data, and there's a fair amount of work required to put it into a common format, to merge it and reformat and so forth. Change data capture is really more for real-time synchronization of source database records. And so in my background, a very common pattern was to use CDC to synchronize on-premises source systems, say mainframe, SAP, iSeries, with cloud-based targets for analytics, so that those cloud-based targets are always reflecting the latest operational reality residing within the on-premise systems. This can work for financial transactions, simply synchronizing different views of the data for operations. It can also work for customer recommendations. For example, to look at a customer that just purchased one item based on their history, based on other things they're doing on the website at that time, that e-commerce firm might recommend another product as part of a cross-selling effort. It can also work for fraud prevention, where financial services organizations need to look across different merchants in order to understand whether there's suspicious behavior. Streaming is an important pattern. Apache Kafka kind of took the world by storm over the last 10 or 15 years. There's also Apache Pulsar and some proprietary systems as well. And this is where you're really trying to orchestrate those real-time events across multiple platforms. You can have sort of a sophisticated web of topic streams, which are sequences of real-time events and actions that are taking place in larger infrastructures. So this will support transactional synchronization, some of the customer recommendations that I talked about. It'll also support Internet of Things sensors that are supporting preventive maintenance. It could support analysis of social media trends to assess customer analytics. Virtualization is going to help with use cases that are pretty similar to the ones I've been talking about. The key distinction being that the complexity is a lot higher of trying to move all that data. And so it makes more sense, given data gravity or other considerations, to analyze the data where it is and provide virtual views that have pointers to those distributed data sets. A very popular use case, given the fact that most organizations are hybrid and multi-cloud. Most enterprises of any size are favoring multiple cloud providers and multiple data centers and regions, simply because of data gravity, sovereignty requirements, and so forth. And so it makes sense for those richer use cases that require a view of all your data, or a good chunk of it, to consider data virtualization. So the key point here is that you want to map your data integration styles to the workloads and the use cases that your data engineering team, your data architecture team needs to support for the business. Okay. I want to pause here, and I want to see, we're going to pull up a poll. I believe that, okay, good. So I've talked about how to differentiate these different use cases, these different styles, and we would love to hear from the attendees. Which data integration styles your organization uses? Data virtualization, ETL, ELT, CDC, streaming, or all of the above? So I'll pause while folks fill this out. And I think we're going to get a real-time view of the results. If not, I believe Lucia will be showing us those at the end. Okay, so this is interesting. 29% data virtualization, 77% ETL. Okay, that's not surprising. ELT 61%, CDC 32, and streaming 32. All of the above 6. Okay, so we can see from the percentage responses here that a lot of folks are choosing, not many folks are choosing all of them, but a number of folks are choosing more than one, 2 or 3. And that fits with a pattern that I will show on the next slide. Good, so this is a good framework and breakout and kind of fits with the patterns and the observations we've had. All right, so we did our own survey here. I did a survey leading up to this webinar on LinkedIn. How many data integration styles does your organization use? And this is a survey of data practitioners in the field. We found that 24% said 1 or 2 styles. 22% said 5 or more, which I thought was pretty surprising. That's actually a higher number than we saw in the results here. And then 54%, a slight majority, said 3 or 4 data integration styles is what their organization's using now. So you can see from this a theme, which is that you need tool sets that are going to help you integrate data, combine or mix and match data integration styles like Lego pieces. I use the Lego analogy somewhat frequently. We have 3 boys and they love Legos, and I think it's a good way to try to be modular in your approach to data integration and IT in general. So if we look at how to combine these 3 common patterns to combine styles are ETL plus data virtualization, where you're taking a given data set and maybe you're sorting it by history, and you're balancing consolidation and virtualization based on data gravity, transformation requirements, and compute costs. Another is streaming ETL. You're streaming the data and you're transforming it in flight, in memory, in order to assist real-time use cases. And then CDC plus ELT was a common pattern from my past, ingesting data from on-premises relational databases as you move it to a cloud. So these are some actual examples. Now, these are fictional, but they fit with what I've observed in the field over the years. The first one, ETL plus data virtualization. Let's say you have a retailer that needs to reduce data consolidation costs by keeping some of their older sales records on premises. Makes sense. If a retailer's been around for a while, they could have a decade or more of historical data. Some of that will be relevant for certain use cases, but not all of it. So they're going to use ETL for BI reporting on their cloud enterprise data warehouse, meaning they're going to say use ETL for the most recent year or the most recent month and bring all that over to the cloud target. But they're going to virtualize the rest. So they're going to use virtual pointers when they need to go back farther in the history and reach back on premises to support, for example, a customer recommendation engine that needs to query the full sales history. Another combined use case here is streaming ETL, where you've got a commercial bank that needs to reduce fraud losses with improved detection. So they need to reduce false positives and false negatives, and they want to correlate more data points in memory without delaying legitimate transactions. And so that's where they're going to use transformation, specifically merging and filtering of topic streams in memory in order to, as data is streaming through, make some quick deductions about risk associated with various transactions. Final point, final use case here is streaming plus CDC plus ETL. IoT is a good example use case. An automotive firm might need to reduce factory costs with preventive maintenance. So they're going to stream IoT sensor messages into their cloud analytics platform, and they're going to merge and correlate those messages with service records that they're synchronizing using change data capture from the relational database. So you really need flexible data pipelines to help mix and match, address combined use cases, and make a healthy circulatory system for your environment. I'll quickly close here and hand over to Nick. I think I'm excited to hear Data Virtuality's perspective on this based on their work with enterprises. But the key point would be prioritize your use cases by business value, their risk, your team's skills, and their alignment with the data environment. You want to enlist the expert data engineers to scope those data integration styles, then map them to workloads and use cases. And you want to design your pipelines to support new topologies that are getting more popular. Might be a lakehouse, might be a data mesh or fabric. We find the best way to go is to start with a small beachhead project and expand. And I think this approach can apply. Organizations are getting new project requests all the time, and you can start to assess those ongoing requirements using this methodology. So Nick, I've gone a little over on time. I'll hand over to you. And I think that in the meantime, Lucia has another poll.
Yes, that's right. And while we change screens from Kevin to Nick, we've got the second poll out, and the question is, which integration style are you looking into implementing within the next 6 months? And the options are data virtualization, ETL, ELT, CDC, streaming, or maybe you're not aware if there is any project on the horizon. We will be very curious to know. By the way, Kevin, sorry, I forgot to say thank you very much for your presentation. It was very interesting.
Thank you. No worries.
I focus directly on the poll as I'm very curious to see what the people are answering. What are the results? Here we go. So interesting. Data virtualization 48%, ETL ELT 19%, CDC 13%, streaming 29%, and unknown no project on the horizon 32%. Excellent. Thank you very much for the results. So without any further ado, I'm going to pass it to Nick for the second part of the presentation. Let's see how we can enable users to have data usability ready. Nick, the stage is yours.
Thank you. Thank you very much, Kevin. Thank you, Lucia. So let me start with my part. And before I get to the juicy parts and start talking use cases, let me share some news, which probably you have kind of heard maybe, but let me explain it just a little bit. So the original invitation to this webinar came from Data Virtuality. But in the meanwhile, we teamed up with a company which is called CData, and now we become one company. Data Virtuality becomes company of CData. And for many of the practitioners out there, they will know what CData is. CData is data connectivity company, which takes care of simplifying access to any data anywhere. And CData does it based on more than 270 standards-based SQL connectors to data sources. These are things like JDBC connectors, ODBC connectors, and so on. So we can connect any tool to any data source using SQL. And this was also one of the reasons why we teamed up, because it's also our shared vision representing all the different things in the world using SQL database language. And with this joint vision, we joined CData beginning of April. And now we have a joint offering together based on the large number of high quality CData connectors. We are providing different styles of data integration, both combined in one product, but also in different products. And we have products with different focus. For example, CData Sync is taking care of ETL, ELT, and reverse ETL. I don't know if reverse ETL is considered another data integration style. I think probably not really, but still. Also, we are providing connectivity, cloud-based connectivity, which is basically providing driver-based access through cloud offering, and also CData Virtuality, which is a data virtuality offering, which based on the large number of both C data connectors and original data virtuality connectors, provides a broad connectivity from different data sources into one central data virtualization solution. And having brought across the news, let me talk a bit more about some of the use cases we see and how different data integration styles are combined there. I have brought a couple of use cases where the architecture was built with a little bit different philosophy, like starting from a different endpoint. First use case comes from a pension fund. It's one of the largest pension funds in the world, and the new architecture was largely driven by IT, and IT, of course, with business requirements in mind. And for IT, it was important to build a centralized data access layer for all the data, which would provide centralized data governance and data lineage. And at the same time, this data access layer would support the hybrid cloud strategy, which the company was running, which involved moving both applications, but also data to the cloud, but not all of it, because for different reasons, it's not possible to move all data, all workloads to the cloud, but really just moving some of it. And here we see how the combination of different things can cater to these requirements. This would include connecting the cloud parts of the environment to the on-premise parts of the environment, providing a single universe data access layer with data governance, and behind the scenes, IT implementing the cloud strategy, moving the application across to different places, also moving data, for example, in this case, to Snowflake, using combination of ETL, EOT approaches, and so on. And this is one case of such combined architecture with different data delivery styles. Another case which I brought is more business case driven. It comes from a retail banking organization, where the question was, how can we help the different business departments to solve their needs while still like making things available in the right way. And for example, if we talk about sales department, about customer relationships department, one of the challenges there was that due to data privacy, GDPR requirements, it was actually not possible to store all the data together in one place. But of course, those departments wanted to analyze those data together. And that's why in one of the use cases, which I present here, it was possible to combine the data warehouse with financial data, which was fed with transactional data from the operational systems using CDC approach, change data capture from the database. It was possible using data virtuality platform to combine this financial data with the customer data in the CRM system, which was a live connection without really storing the data together. And it was catering to sales department for real-time sales monitoring, to risk management department, credit risk calculations, and so on. And also, for example, for marketing analytics department, but not only with this, but also in combination with web and online marketing data, which were brought over using ETL approach from a number of SaaS analytical offerings on the cloud, which allowed controlling and analyzing marketing and sales channels online. So I cannot really go very deep into any of these use cases because it's like very interesting business situations happening there. I just wanted to provide you with a glimpse of how the combination of different data integration styles is being used by different organizations in different situations, also looking from a different standpoint, from IT standpoint, from business standpoint. If somebody's interested, feel free to get in touch with us. You can also directly start a trial on our platform and experience it yourself. You can also contact Lucia directly. We have her email here. And with this, I would like to thank you for your interest. Any questions which we were not able to answer here due to a short time will be answered via email. Thank you very much. Over to you, Lucia.
Thank you very much, Nick. Well, very, very interesting. And indeed, we've got 3 questions coming through the chat. And I know we are already on top of the hour, but maybe since those are valuable questions, I would like you guys to take them if you've got 5 more minutes, if it's all right. So the first
Sounds good.
question, great. The first question I think is related to Kevin's slides, and it's, can you please explain the acronyms for those of us not familiar with them? And here it's referring to the acronyms on the data integration styles.
Okay. ETL, extract, transform, load, is the sequence. You're extracting data from a source, such as a relational database. Maybe you're extracting files from a repository, a cloud object store, and then transforming it in flight, say on an intermediate server or intermediate cloud cluster, and then loading it onto a target. And then I went through acronyms kind of fast, so apologize for that. The variations on that are ELT, where you're instead you're extracting, loading, and transforming, meaning you're taking it from one place, putting it in another, and transforming it on the target. I talked about some of the other variations, ELTL, extracting, loading to an intermediate landing zone, transforming it there, and then loading it on the target. So those are some of the acronyms Nick brought up, which I think is really important, reverse ETL. And that's where you have data that's already within, say, a data warehouse, and applications want to consume that data, often for operational use cases. And Nick might elaborate. It sounds like you've spent some real time there. But that's the quick cheat sheet.
Thank you. Nick, would you like to add anything on that?
Yeah, I think I'm good. So for reverse ETL, I think on high level, Kevin answered this very well. So some of our customers, especially I mentioned some business use cases where, for example, marketing or sales is involved. So marketing automation is obviously a great and growing space, and feeding this marketing automation space with data is something reverse ETL is very helpful for our customers.
Great, thank you both. I've got the next one waiting up for you, and I think also this is a very interesting one. Why not use ETL for complex business transforms? Who would like to take that?
I'd be happy to take the first swing. It's I think my assertion was, if you have a lot of complex transformation, the reason would be that intermediate server or the intermediate cloud cluster that needs to perform the transformations might be overwhelmed by the complexity of it. And it might be more efficient and more cost-effective to instead perform the transformation in that case in the target, which would be, as an example, a data lakehouse or a cloud data warehouse. So that's the reason. It's a question of how much you can tax that intermediate server, whether it has the processing power to cost effectively perform the transformation. I'd welcome any other thoughts from Nick.
Yeah, I would agree. So that's like having complex transformation is not like decisive factor for one or the other. It's rather like how your concrete infrastructure looks like and where you can run complex transformations on the database or in between.
Right.
So that's a great example of how you need to map those workloads to your environment and to your choice of integration styles.
Perfect. And then I think I'm gonna just choose the last question for the interest of time. And this one is, what is the typical amount of time taken to develop such solutions of this scale?
So I would. Do you want?
Yeah,
to?
please, Nick.
Yeah,
Maybe
yeah.
go ahead.
Yeah, I would probably start talking about this. The amount of time is usually rather small when you have a combination of different data integration technologies. And it's small, especially in the comparison to the cases where you use one predominant data integration style, something like ETL or EOT, and you actually put all your data in one place physically. So this is something which usually takes a lot of time, and combination of different integration styles allows you actually to avoid this long initial delay, which is basically between you start putting your data into like data lake or data warehouse or whatever, wherever your central place is, and then running business use cases on top of it. With combination of different data integration styles, especially with data virtualization, it allows you to start doing use cases from the beginning, before having put all the data in one place. And depending on how you do your project, you can start delivering first use cases in terms of weeks. So, for example, this retail banking use case, which was more business driven, indeed, in first 2 weeks there was a regulatory report live going out to the central organization. In the other cases, whereas like there's additional central concerns, like let's do data governance, let's also build a data catalog, let's organize the data. It can take more, but in any case, the initial step is usually taking several months, like 2-3 months until the first iteration, and then you can continue iterating on.
Very good. Thank you very much, both. Thank you, Kevin. Thank you, Nick. With this, I'm gonna call it because we are already 7 minutes past the time. We still have some questions coming in, and indeed are very interesting. So we'll make sure that we will get back to you per email, and we'll respond to you those questions. Thank you very much, everyone. Thank you, Kevin. Thank you, Nick. Very, very interesting topic. We hope to see you next time. Thanks a lot, everyone.
Thank you very much.
Thank you very much. Bye-bye.
Bye.
Bye.